Hello everyone to this first lecture about matrix. Matrix is a rectangular array of numbers, so it must be in a rectangular form. For example, it must be like that. That means we can't say that numbers in a triangular form or in a circular form are matrix. So matrix is always in a rectangular form. And it consists of numbers. So it has some rows and columns of numbers, and the intersection of the rows and columns are called the entries of the matrix. For example, in this example here we have this matrix that have 3 rows and 2 columns. So, and at each intersection of this row here, and this one here, and 2 columns here, at each intersection we have an entry of this matrix. And this can be any number, so it can be a real number or a complex number. And usually we define a matrix by its size. Its size means the number of rows and columns that matrix has. So for example, if we say that a matrix has m rows and n columns, so we say that this m by n matrix. For example, the example here we have 3 rows and 2 columns is called a 3 by 2 matrix. And we always start by the number of rows and then the number of columns. So this is how the matrix are defined. We define a matrix by its number of rows and its number of columns. And it can be represented by parentheses like this or by brackets like that. So it has the same. So these two matrices are same. There is no difference between representing a matrix by brackets or by parentheses. And we can define a matrix like that. So we say that matrix called A is represented by m rows and n columns. And the aij is the entry at the I row, so I row, and G column. For example, if we have a matrix with three rows and 4 columns, this matrix can be represented like that. So we have here A11, so at the first row here, first row, and at the first column here. And here at the second row we have A2 and 1, because here is the second row with the first column, and the same here we have the third row and the first column, so it is 3, 1. And for the 1, 2, it is the first row and the second column. Each we get the first row here with the fourth column, and here is the third column. So this is a 3 by 4 matrix, so it has 3 rows and 4 columns. And we call a matrix with just 1 row, like this one here. We can represent this with parentheses or with brackets, no difference. So here we call it a row matrix. It has just 1 row, and in this example here it has 4 columns. And the opposite, if we have a matrix with just 1 column and many rows, in this example here is 3 rows, in this case we call it a column matrix. And this one here is called a row matrix. So this is a row matrix because it has just 1 row, and it can have many columns. And this one is a column matrix which has just 1 column, but it can have many rows. Here I will define some properties of the matrix. The first one is the square matrix. So we say that a matrix is square, it has the same number of rows and columns. For example, matrix which has m equals n, we say that we represent the number of rows by m, number of rows, so the number of rows, and the number of columns by n. So if we have a matrix with same number of rows and columns, we say it is a square matrix. Like the example here, we have 4 rows, 1, 2, 3, 4, and 4 columns, so 1, 2, 3, 4. So this matrix is a 4 by 4 matrix, or it is a square matrix. The main diagonal of matrix is the entries at the diagonal of a square matrix. So the main diagonal is defined just for the square matrix. In this example here, we have this main diagonal. So it is like that. Just A1, 1, A2, 2, A3, 3, and A4, 4. So the entries at the I row and I column. So when I is equals G. In this example here, 1, 1, and 2, 2. So in this row, and in this row, and in this column and this row, and also in this column and this row, and in this column and this row. So this is the main diagonal of a square matrix. And we say that two matrices are equal if they have the same size. So two matrices are equal if they have the same size. So it means they have the same number of rows and the same number of columns, and the corresponding entries here, corresponding entries are the same also. So entries are equals. They have equal entries, are equals. Like the example here, A and B here are equal because they have A here is 3 rows and 2 columns, so it is 3 by 2 matrix, and B here also is 3 by 2 matrix, so they have the same size. And the entries here are equals also because 1 here and 1 here, 2 here and 2 here, 3 here and 3 here, 4 here and 4 here, 5 here and 5 here, 6 here and 6 here. And we say that A and B are equals. However, C here is not equal to this 2 matrix, so because it doesn't have the same size, C here is 2 rows and 3 columns, so it is 3 by 2, which is different from this 3 by 2 here. We don't here isn't 6 because we don't do multiplication, so it's just a notation here, so isn't a multiplication. And the matrices here are different because they don't have the same size, even if it looks they have the same entries here 1, 2, 3, but they don't have the same size, so we can't compare them and we say that they are not equal. And even if we have a matrix with same size here, like for example a matrix with 3 rows, like for example 1, 2, 4 for example, and 7, 8, 3 for example, this matrix is different from B because it has the same size. It is a 3 by 2 matrix, but the entries here are not equal, so this matrix is different from these two and also different from this matrix. And we define the zero matrix as the matrix with 0 entries. So any matrix with any size which have all the entries are 0, so all the entries are 0. See, it is called zero matrix with size mn, and its role here is like the role in scalar numbers. For example, if we say that 1 plus 0 is equals 1, so the same here if we say that A here for example is 1 ig of mn plus matrix 0 matrix with mn, it is equals when we call this A is always equals A. So it does the role that 0 does in the scalars. The identity matrix is a square matrix, so it must be a square matrix, which means it have m equals n, the number of rows equals the number of columns, and the main diagonal of an identity matrix must have ones, so ones at the main diagonal and 0 elsewhere. And we note it by in, so if matrix with for example 1, 1, so till the n rows, and all these are zeros, so in this case we call it in.